Welcome to doassignment-ca. Here is the problem. Crate A weighs 100 pounds and crate B weighs 50 pounds. A horizontal force P equal to 50 pounds is applied to crate A, pushing it into crate B so both crates slide together on the ground. The coefficient of kinetic friction between the crates and the ground is mu sub k equal to 0.25. If the crates start from rest, determine first their common speed when t equals 5 seconds, and second, the force exerted by crate A on crate B during the motion. Now let's work through the solution step by step. Here is the free body diagram. Crate A, weighing 100 pounds, is pushed by P equals 50 pounds to the right. Through contact, crate A pushes crate B with force C to the right, while B pushes back on A with force C to the left. Both crates have weight and normal force balancing vertically. Kinetic friction acts backward under each crate, 25 pounds under A and 12.5 pounds under B. Since both crates move together, we treat them as one system and apply the linear impulse momentum principle. The given values are weight of A equals 100 pounds, weight of B equals 50 pounds, applied force P equals 50 pounds, coefficient of kinetic friction equals 0.25, time equals 5 seconds, and initial velocity equals 0. The total mass is 150 divided by 32.2, which equals 4.658 slugs. Kinetic friction under crate A equals 0.25 times 100, giving 25 pounds. Under crate B, it equals 0.25 times 50, giving 12.5 pounds. The total friction force opposing the system's motion is 37.5 pounds. For the whole system, the impulse momentum equation in the horizontal direction gives net force times time equals total mass times final velocity. The net force is P minus total friction, which is 50 minus 37.5 equals 12.5 pounds. Multiplying by 5 seconds gives 62.5 pound-seconds on the left and 4.658 times V sub 2 on the right. Dividing 62.5 by 4.658 gives the final speed of approximately 13.4 feet per second, directed to the right. Now we isolate crate B. The contact force C acts forward on B, and friction of 12.5 pounds acts backward. The impulse on B equals B's mass times its final velocity. So C minus 12.5 times 5 seconds equals 50 divided by 32.2 times 13.41, which equals 20.82 pound-seconds. Dividing 20.82 by 5 gives 4.164 pounds. Adding 12.5 gives the contact force C equal to approximately 16.6 pounds. By Newton's third law, crate A exerts 16.6 pounds on crate B to the right, and crate B pushes back on A with 16.6 pounds to the left. To summarize, the common speed of both crates at 5 seconds is 13.4 feet per second to the right, and the force crate A exerts on crate B is 16.6 pounds. The verification using Newton's second law gives an acceleration of 2.683 feet per second squared, and multiplying by 5 seconds confirms the speed of 13.4 feet per second, which matches. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.